Hi everyone, so we're doing another video on differentiation, and this time we are looking at the product rule. So of course, as the name suggests, it has to do with product, multiplying something, right? So if you are given a function with a product, you use the product rule to differentiate that function. Let u be your first factor and v be your second factor, and use the rule here to differentiate. So you differentiate the first and hold the second product, and you add it to differentiating the second times the product of holding the first. So of course that sounds like a lot of gibberish, maybe, depending on how much research you have done. So let us get into it using the example. Find the gradient of the curve y equals so. Remember we said that when you differentiate a function, you are actually finding the gradient of the function, right? At that point, you are finding the gradient of the function. So I ensure to rewrite or reword my question so that you're exposed to the different ways the question can be asked. The question can be plain and simple and say differentiate, or it can say find the derivative of, or it can say find the gradient of the curve. All right. So we have a product here. So our first factor in this case is our bracket. So let u equal x plus 2 squared, and let v equal x cubed. Now if you observe, you will recognize that you have to use the chain rule to differentiate u, right? So without writing out all of the excitement of using the chain rule, you can just go ahead and do it. So du by dx is gonna be the differential of outside, so that's 2x plus 2 power decreased by 1 times derivative of the inside, so that will be times 1. Why? Because we have x alone here, and when you differentiate x, I get 1, right? So that's the derivative of u right there, which when simplified is just 2 times x plus 2. And then we differentiate v. So we are looking at dv by dx, which means that we're differentiating v with respect to x. So power rule, multiply by coefficient, decrease power by 1. So we have differentiated the parts. Now just you're not seeing it, so let me write it back there. The differentiation of the product is that plus that times that. So differentiate the first factor, which we did and got du by dx. So we're gonna say dy by dx is equal to u prime, or the derivative of u, which is 2x plus 2 times original v, so that's x cubed, plus the derivative of v, so that's 3x squared, times original u, so that's times x plus 2 to the second power. So we can try and simplify this. It is going to be 2x cubed times x plus 2 plus 3x squared times x plus 2 to the second power squared, or to the second power. If you want to, you can try to simplify this, or you can let it stay. It should not be any problem. Let's look at another example that does not include chain. So we have y equal x plus 2 times 7x minus 1. So first thing, let u equal the first factor. So let u equal x plus 2. And let v equal the second factor. That's going to be 7x minus 1. We're going to differentiate u with respect to x. When we do that, we get 1. And we'll differentiate v, so dv, with respect to x by dx, we get 7. So as I have there, and different people actually state it differently. So some will actually differentiate the second. Some will write it as v prime u plus u prime v. But it's the same thing if you look at them carefully. Alright, so dy by dx is gonna be equal to u prime or du by dx. So that's 1 times v, so 7x minus 1, plus v prime, so 7 times u, and u is x plus 2. So derivative of first times original second plus derivative of second times original first. And you can simplify. So if I simplify this, 1 times that would give us the 7x minus 1. 7 times that would give us 7x plus 14. How we get that? 7 times x and 7 times 2. Simplifying this further, we get 14x and negative 1 plus 14, that would be 13, right? So dy by dx is ultimately equal to 14x plus 13. I hope you learned something. If you need more examples on the product rule, let me know. Thank you.